All right, Chem AP Aces, are you ready? We've got another Chapter 4 lab for you. This one's a Redox lab, okay? And it's going to involve titration, which we'll show you in a minute, but first you need a little bit of background information. So, what we're doing is we're going to react hydrogen peroxide and potassium permanganate. All right, so we're going to have a permanganate solution with a known concentration, 0.150. That's going to be in the burette. It's got a really nice deep purple color. And we're going to use that to titrate a hydrogen peroxide solution. And later on, we'll tell you what question it is you're trying to determine. Okay? And you need to know this maybe. In acidic solution, permanganate ions change to Mn+2 ions, and hydrogen peroxide molecules change to oxygen molecules. You're going to need that information. You're going to have to try to create a net ionic equation for yourself so you can do the stoichiometry in the particular drug.
Will we have to balance the net ionic equation too?
I would think you need a balanced net ionic equation. Did I not say that, Mr. Moore? Probably not. Or don't balance it. It's fine.
Doesn't matter.
Doesn't it? Yeah,
Okay.
whatever. Yeah.
So we're at our chemistry lab station.
All right, yeah, here we are. Time to do the titration. As you recall, we said the permanganate was going to be in the burette. It's got a beautiful
What a
color.
color.
Yeah. And recall, we know this concentration is 0.150. Okay, so we'll use that permanganate then to titrate against our unknown hydrogen peroxide solution. You are using sample D.
Okay.
Okay? So we're going to have to measure out some of the peroxide solution. Here's the cylinder that I'm using. Well, you can see the graduations. This cylinder is graduated in 1/10 milliliter increments.
Oh, the iPad doesn't want to focus on
Does my hand cause a problem?
it. I don't know. It's not. Okay, there we got it. So yeah, you can see the graduations on it are to the 10th. So when you measure out 10, we can call it 10.00.
So, there's a dropper here so we can try to get as exactly close as we can to 10.00. Okay.
Mm-hmm.
Put that in our reaction flask. Okay, now, as you well know, these aqueous redox reactions tend to be in either an acidic or a basic solution. This one has to be acidified to work.
Mm-hmm.
And so Mr. Moore made up some 6 molar sulfuric acid, and we're going to give a couple good healthy squirts because we need hydrogen ions to make this reaction work.
So you're not measuring the sulfuric acid.
Right, we don't need an exact volume of it, we just know we need a big excess of hydrogen ions.
Mm-hmm.
And the hydrogen ions are what important. The sulfate ion from the sulfuric acid doesn't make any difference, it's a spectator.
Mm-hmm.
So now we're ready to titrate.
So no reaction has happened between the acid and the peroxide. We've just added the acid to it. It's now acidified hydrogen peroxide.
Right. And so now we'll start adding our permanganate to it.
Okay, so it starts at 0.
And, oh, one other thing too, I almost forgot. Permanganate is its own indicator.
Oh, yeah.
So you recall the last acid-base lab, we had to put phenolphthalein in so there was a color change to mark the stoichiometric point. Well, permanganate's nice because it has its own color change. The permanganate ion, the manganese, is in a different oxidation state than at the end. Right now it's got a nice deep purple color, but you're going to see that disappears because Mn+2 is colorless in solution. And so you see that purple very quickly disappear because there's a big excess of hydrogen peroxide.
A lot of transition metals are like that. They'll be a different color for their different oxidation numbers. And manganese is one of those.
Yeah. Now, there's something else going on there, Mr. Moore. It's not just
Yeah,
a
what else
color
do we
change.
see happening? Is that bubbling just from mixing the liquids together? It doesn't look like it. I think the bubbles are part of the
It's
reaction.
part of the reaction,
When we look back at our chemical equation, when you do a lab, it's important to connect what you see in the chemical equation and make sure it's consistent with what you're observing. So the color is going away because the permanganate hits it and changes oxidation number. It goes to a clear. When we've run out of hydrogen peroxide, there won't be anything left in there to change the oxidation number permanganate, and then it will just stay pink. That's what we're looking for.
yeah. Right.
And I think we're close.
Oh, I thought that would be the drop. No, still not quite
Still
there.
going. Oh, it's clear.
There we go.
You got it. Okay, good endpoint. One drop to get us there. So our final volume on this trial. It's hard to get a read on the burette with permanganate because you can't see through it to see the meniscus, and it's focusing on the cabinets behind. Darn. Okay, there we go. Come on. Yes. Can you put your hand behind that? Oh no, we got it. Just came in. All right. So Mr. Hevel has done 2 good trials with A, 2 good trials with B, 2 good trials with C without overshooting.
Pressure's on.
Now you have 1 more, trial D,
Trial D.
or sample D.
Well, you know, Mr. Moore, if I overshoot it, it's not our grade.
Yeah.
So. What am I worried
It's
about?
really not a big deal.
Okay, a couple big squirts. Acid. Ready to go again.
Okay.
So we should be able to take it down to about 22 or so
22 or
pretty
so, yeah.
quickly. It's always funny in class when students forget to add the acid.
Mm-hmm. Easy to do.
Yep. And then you never get the color change.
Okay, we're getting close.
Okay,
Just
we're
hit
getting
21.
close.
You got
Looks
it.
a little pink, doesn't it?
Perfect day. Good job.
Thank you.
All right.
Great. So remember that you'll see later what the actual question will be, what you're going to attempt to calculate.